All right, so Subversion is what's basically referred to as a version control system, which means that basically it is a tool to keep track of changes in files. And so what this ends up doing is it works in this model where you check out some directory of code or whatever, and then basically you make changes to it, and then you commit that code, and then it keeps a list of basically all the changes that end up happening to that code. And this, for things like source code, happens on a line-by-line basis. And so what that enables you to do is if there are several of you working on the project, each of you can check out a version of the code, you can make changes, you can commit those changes. That goes along with metadata such as a commit string. And so what that enables your teammates to do is pull down those changes, and those changes get merged in with their changes. And so this enables you to work together on this project, and hopefully never get to the point where you have to like share something through Dropbox and be like moving files around by hand and that kind of thing. That's specifically the kind of thing that you're trying to avoid by using a version control system. So let's see, I guess this is what I just said. Oh, and also something that's nice about this is that since it keeps track of all of your versions, if by chance you develop something and you break it and you don't know how to get back to the state you were at, version control allows you basically to revert your code back to the state where nothing was wrong with it. Or if someone makes a commit that breaks something and you don't know what that was, then you can revert that and you can deal with it in that way. So something I will say is that a lot of SVN, or a lot of version control in general, has a very strong background in command line interfaces, and that's sort of been the I guess the standard for a long time in these kind of things. And even things like Git, which I guess Git and was it HG or Mercurial are still best supported through command line interfaces. There have been developments of GUI-based versions for these things, which I'm getting ready to show you, such as Tortoise Git or Tortoise SVN. In this case, for Windows, a lot of IDEs have version control tools built into the IDE, so it's a lot easier to use. I will say, though, that if you ever get into something very complex and nasty with version control, then you might have to learn how to use the command line interface to actually get it done. If something gets messed up in the repository or something like that, then you might have to learn the command line for it. Some of the common tasks that go along with this, you can see it's checking out, which means actually getting the code from the repository. Commits, which is, like I said, pushing changes to the repository. There's some strange things about renaming, deleting, and adding files. Updating is whenever you pull down changes from the repository to what's called your working directory. So your working directory is basically just your files on the actual machine. So updating basically brings the changes out of the SVN server and merges those with your local changes in your local working directories. And sometimes what can happen when you do this is you can get conflicts. And so say I modified line 2 to say, I don't know, int cx gets cy plus cz or something like that. And then this guy I'm developing with, he makes a similar change on the same line and commits that in another version. And whenever I go to commit my code, what I have to do before I do that is I have to pull down the changes, and what SVN will end up telling me is that there's a conflict. So this line has been edited by 2 different people, and so there's a little process you have to go through to resolve that issue before you can actually commit your changes. And so we'll go over that here sort of once we get through these other issues. So SVN in particular has this directory structure, which, for better or worse, has sort of become a standard in SVN repositories, where at the very top directory of the project repository you have these three directories. You have trunk, branches, and tags. Basically, trunk is going to be the main folder of interest for you guys. Trunk is the directory under which the current working version of the code is under normally. So this is where you normally are going to be pulling and pushing to, and there'll just be one copy of the code under that. There's these other directories called branches and tags. Branches will have a whole bunch of subdirectories under it, basically for any branches that you create. So branches are other versions of the code that you commit that normally what will end up happening is a developer or group of sub-developers will make a branch for a particular feature or something like that, and then they'll work in there on those changes until they're ready for those changes to be integrated back into the main version of the code. And this is basically just so that they can work without having to worry about sort of disturbing what's going on in the trunk. Tags are very similar to branches. There's not much of a semantic difference there. One thing that I will say is that in SVN, branching is kind of nasty, and that it's whenever you create a branch, it basically just creates a copy of all of the code, and then you work in it, and then whenever you merge it back, there's just one huge commit where it merges the branch back into the trunk, and so it all comes at one point in time, and so any history of the branch gets lost. So it's kind of nasty in that regard, and can actually be quite a pain to deal with. So the first thing that you normally do when working with SVN is you check out a project. And so what that means is, given a project URL, you go to that URL, you find the project directory that you're concerned with, and then you check out that code. And basically, from there, it proceeds to pull down all of the code onto your local machine, along with some extra little goodies to keep SVN informed about what's going on. And so I have a sort of a little repository set up that I'm going to sort of demo some of these things with, so that you can kind of see it happening. So let me go ahead and delete this. There, let's see. So once you install Tortoise SVN, which I believe their installer is really straightforward now, there's not really anything that complex involved with it. Once you install it, what will happen is you'll have this sort of the context menu in Windows will get updated, so that you have these particular SVN options here. These are options for Tortoise Git, which is for using Git. And so you can see here on the top level directory, I can do SVN checkout. I have a directory here, which this URL is actually the URL of the repository that my lab uses, and so there's untold number of projects and changes in this repository. If you open up these little dots, you can sort of browse the repository, which I'll show you here in a sec. You do have to use a username and password normally with SVN, unless it's an open SVN. If it's something like an open source repository, normally you can check out without giving a username and password. But if you want to commit them, you have to have a username or password, because you have to have the right credentials to do so. So I'll just go and log in. I suggest saving authentication, as otherwise you have to go through this little dialogue over and over and over again. So you can see here, this is the top branch of my repository. And so you can see all these subdirectories, which in the case of this repository, these are all sub-projects. And so if I open up any one of these, I can see that it sort of has this structure that I was talking about, where you have branches, tags, and trunk. You look into the trunk, this is sort of the top level directory, and these are all the files that are actually the working version of the project. This project has actually been dead for quite some time because we moved to Git. But anyways, okay. So here I have the studio test project that I set up. Basically, if you want to add a file, you can actually add files through this repository browser here by just right-clicking on things and saying add file or add folder. But I'm going to go ahead and check out the studio test directory here into this working directory. Just let it go. So you have this little dialog window that comes up. And here, this is actually... So this is actually my working directory here. And so if I go in here, it's empty. I haven't started really doing anything yet. So yeah. So it's kind of up to you. I think what we'll end up doing, like in this class, is that because you're going to be changing team members for each project, it's kind of hard to manage having different permissions set up on like one repository for different team members. And so what will probably end up happening is you'll actually have different repositories, which will actually be like different instances of SVN repositories. A lot of organizations, if they have multiple projects, they will chunk it into like one repository and just have subfolders for each of their different projects. Some caveats about that. If you do that, then basically the versioning numbers for the whole repository count for all the sub-projects. And so if you start making commits in project folder A and someone starts making them in B, it's fine for them to go on separately. But the version numbers will skip around because there will be versions affecting like other places in the code. And it's not that big a deal. Yeah, Git works a little bit differently, and in that case it is best for it to be sort of on its own. The thing is with SVN is like a very sort of recursive system where basically any subdirectory in SVN can sort of act as its own repository, and there's no real difference between it being its own repository and it isn't. Whereas Git, you only have like the top, and you can't check out like the sub pieces very easily without just checking out everything. So that's sort of the main difference. Git does work differently in that manner. What Git does when it creates a branch is it actually is a referential branch in that it keeps track of all the changes that you make, and then once you're done with that, when you merge back in, it takes all of your commits and puts them back into the master branch, and they get interwoven with any commits that have been going on there. And so in that regard, it's a lot better for tracking actually the work that was done in a separate branch. And for that reason, Git is a lot more desirable for that kind of branching paradigm of working on things. Yeah. something like the main, I feel like I'm getting off track kind of, and I don't want to mix in too much Git and SVN because it might be confusing. But if you like look at Git on GitHub, which is sort of like the main Git website out there for open source projects, basically there's a bunch of different ways that you can sort of branch the code. You can do what's called forking, which makes your own like personal branch of the code, or sort of like a copy, and then you can move things back and forth between your personal fork or branch and sort of the main like project's branch. And I'll show you guys a little bit of GitHub here at the end. It has a lot of nice features. I'm working on some stuff using GitHub right now. I'll show you how it works. So we're going to get through the SVN stuff, and then I'll talk about Git a little bit. Right. So we just went over SVN checkout. Commit is sort of the other thing that you're going to be doing very often. I'll just go ahead and show you how to make a commit real quick. So in this empty project that I have here, for all intents and purposes, I will just make a new text file or something. So test doc. So I go in here and I say something like line 1, programming studio, lab session 1, line 2, okay. If I go ahead and save that. So something that I'll call your attention to here is that you don't, in Tortoise SVN, they use like little icons on the files to sort of show you the status of that file, and so you don't see anything here on this one. Whenever you do add a file into SVN, you have to specifically add it, and so you can see here under Tortoise SVN there's this add thing, and so it does show the little icons. Sometimes it's really bad about updating them. But you can see here on the top level directory has this exclamation point, which means that there's changes. So if I go ahead and go to SVN commit here, this will show you this little dialog where right here, this window is where you can put a message basically of what the change is. And so this is very important for documentation purposes. So what you should do in this message is you should put a concise and informative message about what the changes actually are, so that when people are looking at the history of the code, they can actually see like what changes were made, and sort of they can see what files were changed also, but it's hard to tell at that level what is actually going on when you have a very complicated project. Will it automatically build changelog? You can get a diff, so which is kind of like a changelog, in that it shows you what lines were changed. Yeah, some people have automated systems like that set up on their repositories. As far as like automatic commit messages and things like that, I wouldn't necessarily go with that too much, because you kind of want a nice, meaningful, concise thing. But I know that a lot of repositories have sort of special like cron scripts and things set up to like automatically update the change logs and things like that. But you won't have that unless you set up something specific with your repository. So here in this message, just say added test doc, and added some lines to it. And go ahead and say commit, and it'll think for a little while, especially if you're committing to as huge a repository as I am. Oh, or just not do it. Well, thought this was going to work. This is actually like a repository that has sort of been like abandoned, so it might actually not be working right now. Oh, okay. So if it works correctly, this is what it'll look like. It'll show you the change, like the different changes that got uploaded, and also the version number here. So this is version number 24,000 something. So, and then you can see here it has a green check for everything's up to date. All the files have a little green check by them. Everything's hunky dory. Right, so if you want to do anything with like files, like changing the name of the file or adding or deleting files, you normally have to specifically do that, especially in SVN. And so basically it'll kind of know if you just change the name of this to something else, but the best way is to go ahead and do a right click, rename it to like text.2 or something like that if you want to, and then that's a change that has to be committed, etc., etc. Delete is also the same. If you delete a file, I think in general it'll detect that it was deleted and go ahead and delete it in the repository once you commit. SVN add, I already showed you SVN add before. Okay, so SVN update is if someone else has made changes to the code in your repository, SVN update basically takes any commits that they've made and brings it back into your repository. So say someone else makes some other commit, you run an SVN update, and if there's no conflicts or anything like that, it just merges all the files in, merges all the changes in, and your repository is up to date. And it'll keep your it'll keep the changes that you've made to the files, and it'll try to merge them. And so basically what that does is it just tries to like take the changes from the incoming conflicts or the incoming commits and your changes and just stick them all together. And so something that I would strongly suggest doing is that anytime that you are getting ready to commit, but you have to update before you commit because someone has made some changes, don't just update, assume that everything's fine, and then commit, because chances are it won't be, and that there won't be any like text conflict. Everything will fit together fine, but there might be some logic problem where some changes they made or break something that you did in your changes. And so what I would highly suggest doing is making sure your project still compiles and making sure that stuff that you did between the update wasn't affected by any commits that you got updated before you go ahead and commit. It's sort of a very frowned upon thing to break the repository by committing code that is buggy. It's very frustrating for people if they can't compile the project after something has been committed or something like that. So as a general rule of thumb, if you can avoid it, don't commit code that will be uncompilable into a repository. It's not very friendly. Right, so just to kind of show you sort of how these things will interact, I'll go ahead and check out Studio Test again. So this is a separate copy of this repository. So these are both pointing at studio test here. And so if I go ahead and make some change to this file, I'm going to say line 3, update change. And then I can go ahead and commit this. Okay, and so now what the case is here is test this repository, test, they're both pointing at the same repository. Test is one commit ahead of studio test. And so to fix this, what you do is you right click, do this SVN update, and this brings in these changes. You can see here it shows you the test dot text was updated, and if I go ahead and update this, if I had tried to commit any changes, it would have warned that the repository was out of date and that I needed to update before I could commit.
Is that the issue? Is that the common kind of issue in your
I will say that most of the time, if you and like some other developer are, as long as you're not working on like the same section of code, it's generally not an issue. But with SVN, it does require that you run an update before you commit the code. If the repository is ahead of some of the code commits since you checked out or updated.
Is this, like, if I'm working in multiple files, does SVN require me to commit each of those individually, or can I commit like an entire directory?
You can commit, basically, you can just call commit on the top level directory, and you can commit any changes that are in the directory. That includes subdirectories, any number of files. I will say in the commit box, it lists all of the things that are going to be committed. And if you don't feel comfortable committing some of those files because you're not sure about the changes in them, or they're not relevant to the change that you're committing, then you can uncheck them and it won't add them to the commit. And so you can kind of control what is being committed. You don't just have to commit everything every time you commit. I've actually been struggling with this quite a bit recently. It kind of depends on the project that you're working with and who you're working with. And as far as frequency goes, you want to commit every time that there's like a unit of work that stands by itself is getting done.
What constitutes a unit of work that stands by itself?
Yeah, so I will say for things like if you just do like a bug fix where it's like, it's a single issue and it's self-contained, it's nice for there to be a commit by itself because it sort of stands alone and people can see that it's been fixed. Things like that. If you're adding new features, that's when it kind of gets more fuzzy because it's, adding features may require adding lots and lots and lots of code. And that's sort of why people like to branch whenever they create new features, is so that they don't necessarily have to worry about the frequency at which they're committing the new feature. And they can sort of back up their work as they go along. They don't necessarily have to worry about other people being dependent on that code in that way. But I will say in several of the open source projects that I've looked at and worked with, there's lots of times there's really small changes, in the commits. There's only a few lines. And sometimes when people add new features, it's like thousands of lines of code at one commit, so it changes depending on the situation.
Do you like to say a business use Subversion process or not like that? You're working on the database. We're working on 1.0 introduction. You have 1.1 work. Subbranch 1.1 to be the individual features or you're kind of doing.
There's not necessarily a hierarchical branch system. Sorry. There's not necessarily a hierarchical branch system, but what I would suggest doing, if these features are not like relevant to each other, you can just create another branch. And that's really all the optimization kind of do is create a branch. So yeah, you can see here, text doc got updated with my changes from before, so these are now both identical. I will go ahead and show you what a conflict looks like, because conflicts are nasty and sort of where people freak out, I think, whenever they first start working with SVN. So I go and make this change to line 3 here, and then this line 3 I go ahead and make some similar nasty change. So they both files and both different checkouts of this have been edited in the same place. So what I'll go ahead and do is I'll commit this one, nasty change. Okay. So that gets committed up to the repository, and so this guy, when he goes to commit his other nasty change, whenever he goes to do that, this is what you guys were asking about before. So you'll get this warning that the file is out of date, and so that it needs to be updated before that you can go ahead and commit. So we'll go ahead and do that. So I call SVN update. And so whenever you run the update, you get this warning that shows you that the files are in a conflicted state. So they couldn't successfully merge them. And so it does this really nasty thing. You get this like this yellow exclamation mark. Okay. So this can be kind of confusing. When this happens, it creates 4 files. Basically, these are different versions of the file at these 2 here at the bottom of the code and previous revisions. This one that's .mine is the version of the code that was in your repository when you called update. And then test doc is a version has been modified to include commit tags. So what that looks like is this. So you can see here it inserts these nasty like bracket tags where no, they're not put in as comments. They're put in this specific syntax here, where it uses the arrows and it uses the revision numbers to sort of indicate which come from where. And so sort of, I think my favorite way to deal with this is to actually edit this by hand and take out the little tags and make sure that this version of the code is what I want, so that I have to manually go through and look at all the changes and make intelligent decisions about what I actually want kept. What you can do is those other versions, you can just rename those to test doc, and you can use that sort of as the merged one. Once you go ahead and make those changes, So if I say I just want to keep my changes, and I delete all of this nasty code that this other person added. So this is a version of document that I want to go ahead and send up to the repository. What you have to do is you have to right click, or you have to tell Subversion that the conflict is okay, that you've dealt with it. And so what you have to do is go here to Tortoise SVN, and then there's this resolved marker here, which go ahead and indicate that the file has been dealt with and that it's okay to commit now. And whenever that happens, sort of all those other files go away. And then I can go ahead and SVN commit conflict. And then everything's fine, and your repository is back at an okay state now, hopefully. So that's how you deal with conflicts. All right, this is what I just went through. Tortoise SVN does have a built-in like conflict editor, which will show you both files side by side, and you can move lines back and forth. I'm not going to go through that. It's pretty straightforward. What it's important to understand is that you need to resolve the conflicts by actually editing the files, and you need to go ahead and say that you've resolved the conflict once you've done that. Evidently, they want you to submit a log file of all your repositories whenever you send in your projects. So just show you real quick how that looks. If you kind of want to see changes that have been made in the repository, you can just do this show log. It'll show all the changes that have been made to the repository over, well, however long you want to look at. And down here it shows you sort of the commit messages, along with the, if you click on these down here, it'll show you the patches, the diffs of the file. So you can see here, this, at this revision, this line was added, that kind of thing. So what I think is going to end up happening in this class is, I think CSG is going to provide you all with SVN repositories, and so whenever you start your first team project, what will happen is we'll figure out who's all on your team, and we'll tell CSG to make you a repository that you can use for SVN, and they'll have it set up with your CSCE username and passwords, so that you don't have to, or so that you actually have permissions set up so that other teams can't go in and wreck your stuff. I will also say though that if you want, you can use Git, which I don't really have time to show you all of the differences with Git here in this class. But I guess sort of the idea behind using CSG's repositories is they're not open, and so you don't have to worry about the whole world seeing all of your commits to whatever project you're working on if you don't want to. But however, that doesn't really have a lot of tools around the code. You can't like browse it in a browser very easily or anything like that. And so there's a lot of, if you look at like Google Code has basically they have free SVN, Git, Mercurial hosting for open source projects. And so if you put a project up there, basically they'll give you a repository. You can browse it. It has like issue trackers, things like that, things to help you communicate about the code, all in like a web interface. in addition to being able to use SVN with it. The thing is that a Google code requires you to open source your project so everyone in the whole world can see it. And I guess the department or Dr. Kaiser thought that might not be the best option for you guys since. Go ahead.
Yeah, when you can get like also GitHub will give you three five repositories. You get your studio. That's a nice studio.
Yeah, that's what I was going to say is that if you want to use something like GitHub, you can. I think you actually have to like send them like a little message that says that I'm a student, and then they'll give you some number of private repositories that you can use for whatever you want. And that's really nice because you get all the extra like benefits of using something like GitHub. Right. So I'll just go ahead and show you guys a little bit about GitHub here. And then if you want to use it, you can come talk to me and I'll talk to you a little bit more about it. And maybe next time I'll go into more detail about it. But no, thanks. Okay, so when you first log into GitHub, you sort of have like this list of events that have happened. This is a project that I'm been working on here recently, and so what you can see is this is the owner ID and this is the project name, and this allows you to just sort of like browse through all the code. You can look at any particular file that's in the code just by looking at it in the browser. I can look at the history of that code. Well, this code doesn't have any history. Yeah. Let's see. Something that will have. Okay. So this is like the Visual Studio project file. So these are like all the different changes for it. If I go ahead and click on any of these, I can sort of see the. Or no, this is not the Visual Studio. This is a particular commit. So I can see all the different changes that were made in this particular commit. I can see the message, the author, and all of the changes that were made in this particular one. GitHub even allows you to do like commenting on like particular lines of code. And so if something's like in a commit that you want to like comment on, like you think it busted something or something like that, you can just like it should just be a little bit. I'll just comment here. Yeah, you can just like add in a comment about the code, and that'll be visible to all of the collaborators on the project. You can kind of see here is that there's other branches going on. Let's see. JP 9000 is working on its development branch, which is totally different. Has some number of commits ahead than the master branch. It's 4 ahead. So you can see those commits here. Yeah, he's using very very meaningful commit messages there. But something that you can do that's sort of unique to GitHub is that you can fork projects, and so that basically makes a copy of the project for yourself. So this is my fork of that particular project, and so it looks exactly the same. It's all the same code. It has the same commit history, and I can update this as I go along and keep up to date with what they're doing. I sort of was working with this before I had actual access to their repository. And so what that allows you to do in GitHub is, see it says here I'm forked from that other project. And so that allows you to do is I make changes in that fork, and then I can submit what's called a pull request. So basically what that means is the code that's in my repository I send it to them and I'm like, hey, I made these changes to your project. Will you consider, bringing those changes into your project? And then, this gives me a way to make a contribution to the project without actually having ownership or rights to commit to that project. And so what you can see here is this is my pull request. So basically my pull request is some number of commits. In this, there's only one commit, and there's some number of files changed that I edited. And then there's some deliberation about whether or not the pull request is okay. I can make more changes to add to the pull request. And have a little discussion. They merged it before we really had much of a discussion, and a discussion ensued afterwards. But so there's sort of a tool to let you contribute to open source projects without actually having to talk to them and get access and everything before you actually do it. So anyways, this was just a little bit about GitHub and why it's sort of nice as a collaboration tool, in addition to just regular source control tools. But Git is a little different from SVN and can be kind of weird. So if you want to use Git, talk to me. Otherwise, SVN is perfectly fine. And people are using SVN all the time, and a lot of people still prefer it because it's really straightforward. So I think that's the end of the lab time. So if you guys have questions, you can come up and talk to me. Otherwise, I'll see you next week.